Okay, so this is skill 18, which is to use parametric equations to represent conics. So basically, the objective of this problem was to create an equation for a hyperbola in parametric form given one of the foci and one of the covertices. So my covertice ended up being 12, 8, and my foci was 9, -6. So my first step, I determined it was a vertical hyperbola, which means that it would open up and down, but also hyperbolas can open left and right, which is the horizontal hyperbola. However, mine was vertical. Now, in determining the center point, this is the complicated way to write it. The foci is h, comma, k plus or minus c, and the covertice is h plus or minus b, comma, k, and the center is h, comma, k. However, basically the center is just the x-coordinate of the foci and the y-coordinate of the covertice. And this is the covertice, and this is the foci. So you can pretty much just get that from the picture. So therefore my center was 9, 8. And so the distance between the center and the covertice is the b value. The distance between the center and the foci is the c value. So the next step was to find the a value. So I just used the Pythagorean theorem, did my squares and my square roots, and I got a to be 13.9. And so the reason you need the a value is because the general equation has the a squared value in it. So now when you're creating the equation in Cartesian form, I don't know if I said that right, the y squared comes first because it's a vertical hyperbola. So that's why it was important to first identify if it's a vertical hyperbola or if it's a horizontal one. And then this is the form of how to write it for a vertical hyperbola. It's y minus k over a whole squared minus x minus h over b whole squared equals 1. And the k and h values come from the center because the center is h, comma, k. So that's the minus 8 and the minus 9 that you see here because the center is 9, 8. And then also the a and b values, well, you're given the b value once you find the center, and then the a value is what we calculated up here. So now comes so now once you do all all the basic steps, you have to fulfill the objective of this problem, which is to create an equation in parametric forms. So since this is a hyperbola, you will use the secant and tangent identities, because if it's an ellipse, you use cosine and sine. So I use the identity tan squared theta plus 1 equals secant squared theta, otherwise known as secant squared theta minus tan squared theta equals 1. So the secant squared theta equals this first half, and the tangent squared theta equals the second half. And this works of how the identity is arranged, because you can use this trig identity and this form, and you're able to express y and x in terms of secant and tangent. So then once you take the square root of both sides and isolate y, you get y equals 13.9 secant theta plus 8, and x equals 3 tangent theta plus 9. So here, using the trig identity, secant squared minus tan squared theta equals 1, and y minus 8, in this form, in this equation right here, I was able to put y and x in terms of secant and tangent, and I set secant squared theta to the first part and tan squared theta to the second part. I took the square root of both sides. And so now, since I've got this in y and x form, I was able to put this, that's the parametric form of it. So it'd be written as x first and then y. So 3 tangent of t plus 9, comma 13.9 secant t plus 8. So that's the final answer. And that's skill 18.